few more questions about the development of the periodic table, and time question 2. So before developing the modern periodic table in terms of the way Mendeleev did it, we just classified the elements according to their atomic masses. So for example, for calcium, that would have just been the top number of the two numbers that we now see, so 40 in the instance of calcium. The reason being, they didn't have the bottom number. It's a fairly straightforward answer, really. They didn't actually know the atomic number at that stage, and so they weren't able to use it because they didn't have it. So it's kind of a fairly straightforward reason in the first instance. So the atomic number wasn't known. And the reason for that is because in the very early days, they weren't aware of the subatomic particles in the way that we now know them. So protons specifically, because obviously that's what defines the atomic number by definition, but also they weren't aware of the electrons or neutrons either at that stage. So they hadn't discovered any of the relevant pieces of information to give them the atomic number at that stage. So they could only use the mass numbers, many of which they did know quite accurately, but the atomic number to order them as we do now just hadn't been discovered at that stage. So once they had done all that, though, and we then started to look at atomic numbers, we can see there are a couple of instances of where the atomic number is actually, and then the mass number are actually then the wrong way around. If you look at the periodic table, you can see them. One of them is argon, okay, and its subsequent element of potassium would be the wrong way around. Potassium's mass number is 39, argon's is 40, whereas their atomic numbers increase, their mass numbers decrease, so they would have been the wrong way around. But obviously argon, we now know, is a noble gas, so does belong in group 8. Potassium is a reactive group 1 alkali metal, so we know it is in the correct group, and again, based on its proton number, we know that's correct anyway. And a second example is tellurium and iodine down the bottom of group 6 and group 7. Now, one of the reasons because of this, and not the only reason, is that the discovery of isotopes helped to make these masses different, because obviously different atomic weights give you these things, because obviously we can have, for example, carbon exists as carbon 12, exists as carbon 13, it also exists as carbon 14 as well. So we've got 3 different mass numbers here, okay, and that obviously is going to give you quite a multitude of different possibilities for the mass number to be different based on the relative ratios of those 3 numbers. So the 3 different masses give you different positions if you were organizing by atomic mass. However, the key thing for isotopes is that their chemical properties are unchanged. Okay, so even though carbon 14 has a mass of 14 and carbon 12 has a mass of 12, the chemical properties are unchanged. So as we now organize a periodic table by group and by reactivity, we know the group 4, for example, in carbon's specific case, and group 7, for example, for fluorine, is correct, and it will stay in group 7. Carbon will stay in group 4, even if its mass number changes because of the discovery of extra mass isotopes.